Hello dear students, as you are aware that there has been a lockdown and none of you are coming to the college through the eConnect, JC eConnect website, we have been conducting classes for the theory. However, lab sessions have got disrupted. So what we have planned is we will give you a complete overview of how exactly the experiments which are remaining that you need to do, how they need to be conducted, and once you are aware of the steps and the procedure during the exam, I am sure if you go through these videos quite often, you will be able to conduct the experiments on your own. Now today what we will do is we will start off with the Charpy impact strength. We already know that impact load is a load where there is a huge force that is applied suddenly for a very short period of time. You already have done ISOD impact test. So today we will do Charpy on similar lines. The observations what we need to take before we conduct the experiment is, for example, this is the specimen of Charpy. We can see that the total length of the specimen will be 55 mm and the depth of the notch is 5 mm. The cross section is 10 by 10 mm and the shape of the notch is a U notch. So you need to compare this, what are the differences between the specimen of Charpy test and an ISOD test. So this is the specimen which we are going to use, and since there is a notch here, the area which is going to take the impact load will be 5 by 10, that is 50 millimeter square. That is what has been mentioned here. Now the energy absorbed due to friction is 1 joule. Now these are the readings which you are going to write in the journal and complete the journal. So we have already given you the readings. So please note down the readings, and the same readings you are going to transfer, and based on this, this will be the final result which you will write, and in the conclusion you will have to mention about why there is a difference between these two values. For example, you can see that for specimen number 1 it is 22 joules and specimen number 2 it is 16 joules. So the angle of swing of the hammer in this case is 140 degrees, while in case of ISOD test it was 90 degrees. Which obviously means that by the time the hammer comes and strikes the specimen, it will contain more energy because it has been released from a greater height. It will have more energy, which again gives a conclusion, or it tells us that Charpy test is normally conducted on those metals or those materials which are harder, which are more tough. Okay, and you can conduct ISOD on those materials which are slightly softer. So these are the basic differences. Now you already know how exactly the ISOD impact test is conducted. We will just demonstrate and show you the procedure to conduct the Charpy impact test. Okay, so machine, and I'll tell you how to go about it. So this is the equipment on which impact tests are conducted, and you can see that the fixture has been removed. Earlier the fixture was here for the ISOD impact test, which made the angle of swing as 90 degrees. Now that has been removed and it has been mounted such that this total angle will now be 140 degrees. Now obviously, since it is going to be released from a higher level and it will contain more energy, when you see the scale here, you will see that the outer scale is for the Charpy test and the inner scale is for the ISOD test, and each division is 2 joules. So we have already done the initial you could say run where there was no specimen, and we found out what is the energy which is absorbed due to friction, and that was mentioned as 1 joule. Now I'll only show you how the hammer is to be mounted and what are the safety precautions that need to be taken. So he'll help me, and he will show you how the hammer is mounted. Make sure that the pointer initially is at 0. Okay, now he'll load the hammer. Now once the hammer is loaded, there is a safety latch that has to be engaged. Please make sure that this safety latch is engaged, because when you are placing the specimen, if somebody else by mistake, if they release this hammer, it is going to be disastrous. So now the hammer is loaded and we have the pointer at 0. I'll just show you. In case of ISOD, the notch was not exactly at the center, it was at one end, and the larger part was put in a slot, and it was tightened, and the hammer came, and the wedge, it hit exactly at the place where the notch was there. Now, another major difference is, in case of ISO test, the notch was facing the hammer. It came and it hit it in this manner. But in this case, in Charpy, what we are going to do is, we are going to place the specimen in such a way that the hammer is going to come and strike at the back of the notch. It is not going to strike in line with the notch, it is going to strike at the back of the notch. And there is no need for any align key or something like that. It is just to be placed and positioned correctly, that's all. So I will show you how exactly the specimen is placed. Now what we need to do here is, here we have two platforms. So we will just place it such that the notch is facing away, okay, from the hammer, and move it forward and push it to the right. That's it. Okay, so this is how the specimen is placed in case of Charpy test. So once this is done, what you are going to do is, you are going to remove the safety latch, release the hammer. The hammer is going to come and strike, the specimen will fail, and wherever the pointer goes and rests, that will be taken as a reading. So this can be conducted on two specimens. You can also see that the shape of the wedge is different in this case. Inside, whatever we have here, this part is going to strike, that is, it is vertical in this case. Now the wedge or the striking part was horizontal in case of ISO. So, once the hammer comes and hits and the specimen breaks, what we need to do is, we need to bring this hammer to rest as quickly as possible. So we will apply the braking lever, we will engage the braking lever, and the braking pads will break the hammer, and it will come to rest as quickly as possible. Another most important precaution that needs to be taken is, when you are conducting this experiment, please make sure that you don't stand in line with the swing of the hammer. Okay, so sometimes it so happens that you stand here without knowing that the hammer is going to come, and because it has a large amount of momentum, even after striking the specimen, it still continues to move. So don't stand in line of this. So when you are writing the conclusion, see, we have seen that there are differences in the readings. When you are writing the conclusion, points like, let's say, the area under the curve, or the area under the notch, it may not be homogeneous in both the cases. It may not be the same. Or the depth of the notch may have a small variation. Even though we say it should be 5 mm, it may not be 5 mm. So these kind of things you are going to write in your conclusion. Okay, so that is how the Charpy test, the impact test will be conducted. Thank you.